Hello everyone, today we are going through exercise 6.3. So first question, here find the maximum and minimum values if any of the following functions given by first function f of x is equal to 2x minus 1 whole cube plus 3. So here we have to find the minimum, maximum and minimum values of the function. So here we will apply second derivative test, okay. So it is the easiest method. So first of all, for that we have to find f dash of x. Okay, first we will find f dash of x. Here it is a square, okay. So 2 into 2x minus 1 plus 3, okay. That is 2 into 2x minus 1, sorry, derivative of f of x is 2 into 2x minus 1 into derivative of 2x minus 1 is 2, derivative of 3 is 0, that is equal to 4 into 2x minus 1, okay. Then next we have to find the critical values, that is values of x. So for that we set f dash of x is equal to 0. F dash of x is equal to 0 implies 4 into 2x minus 1 is equal to 0, that implies take 4 right side, so it will be 2x minus 1 is equal to 0, that implies x is equal to 1 by 2. So x is equal to 1 by 2 is the critical point. Okay, next we will find f double dash of x. Okay, for second derivative test we need to find second derivative, that is f double dash of x, derivative of f dash of x with respect to x. It is our f dash of x, so we have to differentiate it with respect to x. So f double dash of x is equal to 4 into derivative of 2x minus 1 is 2, right? 4 into 2, that is equal to 8. Here it is greater than 0. See, we have got f double dash of x is equal to 8. That means f double dash of 1 by 2 is equal to 8 according to the second derivative test. See, what is our second derivative test? If f dash of c is equal to 0, here f dash of 1 by 2 is equal to 0, right? Okay, and f double dash of c, that is f double dash of 1 by 2 greater than 0, then the given function has minimum value. Okay, the given function has minimum value, or we can say 1 by 2 is a point of the minimum value of the function. Okay, so here, so we can say f of x has minimum value, okay, if f double dash of c is greater than 0, then the point given point, that is critical point, is a point of minimum. Okay, has minimum value at x is equal to 1 by 2. And what is the minimum value of the function? Minimum value of the function is nothing but substitute x is equal to 1 by 2 in f of x. Okay, it's our point of minimum. So here minimum value of the function is nothing but substitute that critical point to f of x. Okay, so here 2 into x is 1 by 2 minus 1 whole square plus 3, that is equal to 2 cancelled, so 1 minus 1 0, so 3. So 3 is the minimum value of the function. Okay, so this function has minimum value at x is equal to 1 by 2 and minimum value of the function is 3. Okay, now let's go to second one. The given function is f of x is equal to 9x square plus 12x plus 2. So first step is to find f dash of x, that is 18x plus 12. Okay, then set f dash of x is equal to 0 to find the critical values, that is 18x plus 12 is equal to 0, that implies 18x is equal to minus 12, that implies x is equal to minus 12 divided by 8, that implies 6 2s are 6 3s are minus, x is equal to minus 2 by 3. So we have got x is equal to minus 2 by 3, it is the critical point. Okay, so next step is to find the second derivative. Okay, that is derivative of f dash of x with respect to x. So f double dash of x is equal to, it's our f dash of x, derivative, find differentiate. So derivative of 18x is 18 derivative of 12 is 0. Okay. So here, see, we have got f double dash of x is equal to 18. Okay. That means f double dash of minus 2 by 3 is 18, right? So f double dash of c is greater than 0. Okay. We have got f double dash of c is greater than 0. Therefore, see here, this function has also minimum value at x is equal to minus 2 by 3, and minimum value of the function is nothing but substitute x is equal to minus 2 by 3 in f of x. Okay, that is f of x has minimum value at x is equal to minus 2 by 3. Okay, because we have got it is greater than 0. Second derivative is greater than 0. Therefore, according to the second derivative test, we say this function has minimum value, okay, at x is equal to minus 2 by 3, and minimum value of the function is equal to 9 into x is equal to minus 2 by 3, substitute whole square, plus 12 into minus 2 by 3 plus 2. Okay. So here 3 square 9 cancelled, minus will become plus. Okay. So 9 cancelled. So 4 minus here 4 3 1s are 3 4s are. So minus 8 plus 2. Okay. 4 minus 8. 4 minus 8 is minus 4. Minus 4 plus 2 is minus 2. 4 minus 8 is minus 4. Yes. Plus, that is minus 2 is the minimum value of the function. And what is the critical point? Minus 2 by 3. That is minus 2 by 3 is a point of minimum. Okay, third function, f of x is equal to minus of x minus 1 whole square plus 10. F dash of x is equal to minus 2 into x minus 1 into derivative of x minus 1 is 1. Okay, derivative of 10 is 0. So then next f dash of x is equal to 0, that implies minus 2 into x minus 1 is equal to 0. That implies x minus 1 is equal to 0, that implies x is equal to 1. Okay, so we have got a critical value. Then next we will find f double dash of x. F dash of x is minus 2 into x minus 1. So minus 2 into derivative of x minus 1 is 1 itself, right? So here f double dash of x is minus 2. That is f double dash of 1 is also minus 2, right? So it is less than 0. We have got f double dash of c is less than 0 and f dash of 1 is 0. Okay. So according to the second derivative test, the given function f of x has maximum value. Since it is less than 0, this function has maximum value at x is equal to 1, and maximum value of the function is nothing but when substitute x is equal to 1 in f of x. Okay, that is f of 1. Okay, so here f of x has maximum value at x is equal to 1 and maximum value of the function is f of 1, that is equal to, substitute x is equal to 1 minus of 1 minus 1 whole square plus 10, that is it is 0, so plus 10. So plus 10 is the maximum value of the function. So next fourth one, fourth function is g of x is equal to x cube plus 1. Okay, let's find g dash of x. G dash of x is equal to 3x square plus 0. Okay, then g dash of x is equal to 0 implies 3x square is equal to 0, that implies x is equal to 0. X square is equal to 0, that implies x is equal to 0. Okay, x is equal to 0 is a critical point. Okay, so what is the next step? Find g double dash of x. That is equal to 3 into 2x, that is 6x, right? So next we have to find here g double dash of 0, right? That is f double dash of c. C is a critical point, right? So here g double dash of 0 is nothing but 6 into 0, that is 0. It is neither greater than 0 nor less than 0, right? So here second derivative test fails. Okay, so next we will apply first derivative test. Okay, if second derivative test fails, next go to first derivative test. So what is our first derivative test? See, we have got critical point. After that we will take that is immediate neighborhood of 0. Okay, critical point. That is, here we will take integers. Okay, it is 0. Then neighborhood points with, that is immediate neighborhood points. So that is less than 0 and greater than 0. So less than 0 is -1. That is right of 0 is +1. Right. So here we will take 2 points, -1 -1 and 1. Okay. Then next we will find f dash of 1, f dash of -1. Okay, so f dash of -1, first we should find this left of 0, okay, less than 0. So f dash of -1 is equal to, here not f, g, okay, given function is g of x, okay. So g dash of -1, g dash of x is equal to 3x square. So 3 into -1 square, that is equal to 3, okay, that is greater than 0. Next we will find g dash of 1, that is equal to 3 into 1 square, that is also 3, that is also greater than 0. See here, the sign of f dash of x does not change, right? So here we can say the function g of x does not attain maximum value or minimum value. Okay, because what is our first derivative test? If f dash of x changes the sign from positive to negative, then the function has maximum value. Okay, and the f dash of x changes the sign from negative to positive, then the function has minimum value. But here g dash of x, that is the function derivative of function, given function, that is g dash of x, it does not change the sign. Okay, from positive to negative or negative to positive. So it is still positive, right? So here in this case we say the function, given function does not attain maximum value and minimum value. Okay, so here the function g of x does not attain maximum value and minimum value. Okay, there is no maximum and minimum values. Look at the second question. Find the maximum and minimum values, if any, of the following functions given by, first one, f of x is equal to modulus x plus 2 minus 1. Okay, so here we cannot differentiate it since it is modulus function. So we will find it directly. Okay, because we know that modulus x plus 2 is greater than or equal to 0, right? Modulus function is always greater than 0. So modulus x plus 2 is greater than or equal to 0. That implies modulus x plus 2 minus 1 is greater than or equal to 1. That is modulus x plus 2 is greater than or equal to minus 1. Okay, because see, modulus x plus 2 is greater than or equal to 0. That is modulus x plus 2 minus 1 is greater than or equal to 0 minus 1, that is minus 1. Okay, so modulus x plus 2 minus 1 is greater than or equal to minus 1. Okay, so here the function, that the least value, the value of the function, so that is f of x greater than or equal to minus 1. That means the least value of the function is nothing but minus 1. Okay, that means the minimum value of the function is minus 1. Okay, therefore minimum value of the function is minus 1. Here there is no maximum value, because see, when x increases, as x increases, f of x tends to infinity. Okay, therefore there is no maximum value, and f of x has No maximum value. Okay. Then second, g of x is equal to minus modulus x plus 1 plus 3. See, here also we know that modulus x plus 1 is always greater than or equal to 0. Okay. So what is our function? G of x is equal to, rewrite is 3 minus modulus x plus 1. Okay. We can rewrite this function as 3 minus modulus x plus 1. Okay. So 3 minus modulus x plus 1 is, see, x plus 1 is greater than or equal to 0. So it is, so here see, modulus x plus 1 is greater than or equal to 0. Okay. So this totally, that is 3 minus modulus x plus 1 will be less than or equal to 3. Right. See, for example, modulus x plus 1 is equal to 1. Okay. So it will be 3 minus 1. Okay. Suppose modulus x plus 1 is 5. So it will be 3 minus 5, that is minus 2. That is also less than 3. Okay. So if modulus x plus 1 is equal to 0, then it will be 3. So that's why it is less than or equal to 3. Okay. That is modulus x plus 1 is greater than or equal to 0. Okay. Then 3 minus modulus x plus 1 is less than or equal to 3. Because modulus x plus 1 greater than or equal to 0. Okay. See, if you are confusing, just substitute some values. Okay. Modulus x plus 1 greater than or equal to 0 means, suppose if modulus x plus 1 is equal to 6. So what is the value? 3 minus 6, that will be minus 3. That is less than 3, right? Okay. So here take small value, that is modulus x plus 1 is equal to 0. It will be 3. Okay. Therefore, this function, this term, totally this term will be less than or equal to 3. Okay. So here it is nothing but f of x, right? G of x. G of x less than or equal to 3. Okay. That means the maximum value of this function is nothing but 3. Okay. Therefore, the maximum value of the function g of x is 3. The maximum value of the function g of x is 3. There is no minimum value, because here also when x tends to infinity, f of g of x tends to infinity. Okay. And g of x has no minimum value. Next function is h of x is equal to sine of 2x plus 5. So here, how to find the maximum and minimum values? Say, since it is not modulus function, we can differentiate it, right? So here we can apply two methods. One is second derivative test. In second derivative test also, you can find the maximum value and the minimum value. And one more test is directly we can write. See, here we know that the range of a sine function is nothing but minus 1 to 1. That is closed interval minus 1 to 1, right? So we know that minus 1 less than or equal to sine 2x less than or equal to 1, because the range of, that is range of my sine value, that is sine function, is minus 1 to 1. Okay. So here minus 1 less than or equal to sine 2x less than or equal to 1. So let's add 5 throughout by 5. Okay. So minus, because our function is sine 2x plus 5, right? So minus 1 plus 5 less than or equal to sine 2x plus 5 less than or equal to 1 plus 5. So here 4 less than or equal to sine 2x plus 5 less than or equal to 6. See here sine 2x plus 5 is nothing but h of x, given function. So here we say the minimum value of function f is equal to 4 and maximum value of the function f is 6. Okay. And another method, see here we can say minimum value of f is 4 and maximum value of f is 6. Okay. So here we can apply second derivative test also. Find h dash of x. Okay. After that, set h dash of x is equal to 0 to find the critical values. Okay. See, what is our h dash of x? See, method 2. H dash of x is equal to 2 cos 2x, right? Okay, plus 5, that is derivative 0. Okay, and here h dash of x is equal to 0 implies 2 cos 2x is equal to 0. That implies, see, cos 2x is equal to 0 when cos 2x is 0, when cos x is 0. Cos x is equal to 0 implies, see, x is equal to pi by 2 or minus pi by 2. We know that cos minus pi by 2, cos pi by 2 is 0, right? Cos minus pi by 2 is 0, cos pi by 2 is also 0. Therefore, here we say 2x is equal to minus pi by 2 and pi by 2. Okay? That is, x is equal to minus pi by 4 and x is equal to pi by 4. Okay? Two critical points. After that, see, what is our next step? H double dash of x. Our h double dash of x is 4 minus 4 sine 2x. Derivative of this h dash of x with respect to x. Derivative of cos 2x is minus 2 sine 2x, right? So 2 into 2, that is minus 4 sine 2x. So next, substitute these critical values. Okay, so you will get h double dash of minus 4 pi by 4, that is equal to, substitute here x is equal to minus pi by 4, you will get minus 4 into sine 2 into minus pi by 4, that will be minus pi by 2. Okay, and we know that sine of minus theta is minus sine theta. Therefore, minus 4 into minus pi, sine pi by 2. Sine pi by 2 is 1. So, minus into minus plus. So, we will get 4. Okay, that is greater than 0. Okay, that means here the function has, it is h double dash, okay, h double dash of minus, that is f double dash of c greater than 0. Okay, so here according to the second derivative test, this function has minimum value, okay, at x is equal to minus pi by 4. Okay, and minimum value is, substitute minus pi by 4 in h of x. Here substitute x is equal to minus pi by 4. What you will get? Sine of 2 into minus pi by 4 plus 5. See, 2 2s are, okay. So, sine of minus pi by 2, that is, sine of minus pi by 2 is nothing but minus sine of pi by 2. Okay, that is minus 1. So, minus 1 plus 5, that is equal to 4. See, same answer we have got, right? That is, minimum value of the function is 4. Next, we will apply this one, okay, at x is equal to pi by 4. We have got two critical points, right? So, x is equal to pi by 4. If you substitute this one, x is equal to pi by 4, find h double dash of pi by 4, you will get, that is less than 0, value less than 0. And substitute this when x is equal to pi by 4 here, what you will get? Sine of 2 into pi by 4 is pi by 2 plus 5. Sine pi by 2 is 1, 1 plus 5 is equal to 6. See, the maximum value of the function is 6. Same value, right? So, here you can apply two methods, okay? Either second derivative test or this direct, okay? Direct method, okay? So, here h double dash of pi by 4 is equal to, here it is our h double dash of x minus 4 into sine 2 into pi by 4 sine pi by 2, that is minus 4, that is less than 0. Okay. So, since it is less than 0, the function has maximum value at x is equal to pi by 4 and h of pi by 4 is equal to, that is maximum value, right? Yes. So, sine 2 into pi by 4, that is sine pi by 2 plus 5, that is 1 plus 5, that is equal to 6. So, here maximum value is 6. I did not find the minimum value. Just substitute x is equal to minus pi by 4 in h of x. Okay, you will get the minimum value. Okay. So, next function is f of x is equal to modulus sine 4x plus 3. Here we cannot apply second derivative test since it is modulus function. Okay, let's find directly. Here we know that we have the sine function is between the values, the range is minus 1 to 1. Okay. So, minus 1 less than or equal to sine 4x less than or equal to 1. Okay. And here, since it is sine 4x plus 3, that is minus 1. Okay, let's add 3. Let's add throughout by 3. Okay. that is minus 1 plus 3 less than or equal to sine 4x plus 3 less than or equal to 1 plus 3. That is 2 less than or equal to sine 4x plus 3 less than or equal to 4. Okay. See, if it is modulus also same value. Okay. If it is modulus also the same value, 2 less than or equal to sine 4x plus 3 less than or equal to 4. So here we say the minimum value of the function is 2 and maximum value of the function is 4. Okay. Minimum value of f is 2, maximum value of f is 4. That's all. Fifth function is h of x is equal to x plus 1, x belongs to minus 1 to 1. Let's find h dash of x. H dash of x is nothing but 1. See here, h dash of x is equal to 1. That means h dash of x cannot be 0, right? It's to find critical points, anything. But here, and h double dash of x is equal to 0 also. So here we can say this function does not attain maximum value and minimum value in minus 1 to 1. Okay? Therefore, h of x does not attain maximum and minimum values in minus 1 to 1. Okay, because h dash of x not equal to 0. Find the local maxima and local minima if any of the following functions. If any of the following functions, find also the local maximum and the local minimum values as the case may be. So first function is f of x is equal to x square. Okay, let's find local maxima and local minima and the point of local maxima and minima. Okay, so first function, here we will apply second derivative test. F dash of x is equal to 2x, right? And f dash of x is equal to 0 implies 2x is equal to 0, that implies x is equal to 0. Okay, so it is the critical point. Next we will find the f dash of x, f double dash of x is equal to 2, that is derivative of 2x with respect to x is 2. So it is greater than 0, right? So by the second derivative test, here f double dash of c greater than 0, f double dash of x is equal to 2 means f double dash of 0 is also equal to 2, right? And by the second derivative test, f double dash of c greater than 0. Okay, so here we have got f double dash of c greater than 0. Then by the second derivative test, we say 0 is a point of local minimum. Okay, local minimum. 0 is a point of local minima and value of local minimum of f is local minima of f is equal to, that is f of 0, that is equal to 0. So minimum value of the function is nothing but 0. So next go to second function, g of x is equal to x cube minus 3x. So here also let's apply second derivative test. So for that first we will find g dash of x, that is 3x square minus 3. Okay, so 3 into x square minus 1, that implies 3 into x square minus 1 can be written as x plus 1 into x minus 1. Okay, so g dash of x is equal to 0 implies, here take 3 right side. Okay, then x plus 1 is equal to 0 implies x is equal to minus 1 and x minus 1 is equal to 0 implies x is equal to 1. So we have got the critical points minus 1 and 1. So first let's consider x is equal to minus 1, x is equal to minus 1. Let's find g dash of x. Okay, so first of all let's find g double dash of x. Okay, so g double dash of x is, g dash of x is this one, right? 6x minus, okay, 0, that is 6x. So g double dash of x is equal to 6x. Then what is g double dash of 1? That is equal to 6. And g double dash of minus 1 is equal to minus 6. Okay. So g double dash of 1 is greater than 0 and g double dash of minus 1 is less than 0. So by the second derivative test, here minus 1 is a point of local maxima, okay, because here f double dash of c less than 0, right? Okay, so minus 1 is a point of local maxima and 1 is a point of local minima, and local maxima value is minus 1 is a point of local maxima and 1 is a point of local minima, because here we have got g double dash of 1 is greater than 0, okay, and local maximum is equal to, that is local maximum value of the function, okay, is g of minus 1, that is equal to g of minus 1 cube is minus 1 minus 3 into minus 1, that is equal to minus 1 plus 3, so minus 2. Sorry, minus 1 plus 3, right? Okay, so plus 2. So local maximum is 2, and see, 1 is a point of local minima, therefore local minimum is, see, we have to find the local maxima, minima and local minimum and maximum values, okay. That is local minimum is g of 1, that is equal to, substitute x is equal to 1. So 1 cube is 1 minus 3 into 1, that is minus 2. 1 minus 3 is minus 2. So here 2 is the local maximum and minus 2 is the local minimum, and minus 1 is a point of local maxima and 1 is a point of local minimum. Third function is h of x is equal to sin x plus cos x, 0 less than x less than pi by 2. Here x is between 0 and pi by 2. So let's find h dash of x, cos x minus sin x, right? Derivative of sin x is cos x and the derivative of cos x is minus sin x. Then h dash of x is equal to 0 implies cos x minus sin x is equal to 0. That implies cos x is equal to sin x. Okay. So cos x is, if cos x is equal to sin x, then what is the value of x? We know that cos pi by 4 is 1 by root 2, sin pi by 4 is also 1 by root 2. Therefore x is equal to pi by 4. This x should be between 0 to pi by 2. Yes, pi by 4 is also belong to this interval, right? So here this implies x is equal to pi by 4. Okay, and here we have got critical point. Next we will find h double dash of x. Here it is h dash of x. Derivative of cos x with respect to x is minus sin x minus derivative of sin x is cos x. Take minus outside, so sin x plus cos x. Okay, now let's find f double dash of c, right? We have to check whether f double dash of c less than 0 or greater than 0. Okay, so here our c is pi by 4, right? That is h double dash of pi by 4 is equal to minus of sin pi by 4 plus cos pi by 4. We have sin pi by 4 is 1 by root 2 and cos pi by 4 is also 1 by root 2. So minus of 1 by root 2 plus 1 by root 2, that is minus 2 by root 2, that is minus root 2. So minus root 2 is less than 0. Okay. So by second derivative test we say x is equal to pi by 4. Pi by 4 is a point of local maxima. Okay. Since it is less than 0, pi by 4 is a point of local maxima and local maximum value is pi by 4 is a point of local maximum, and local maximum value is, that is h of pi by 4, right? That is equal to, substitute x is equal to pi by 4 in h of x, sin pi by 4, sin pi by 4 is 1 by root 2 plus sin cos pi by 4 is 1 by root 2, that is equal to 2 by root 2, that is root 2. Okay. So root 2 is the maximum value. Fourth function, f of x is equal to sin x minus cos x. See x between 0 and 2 pi. Okay. So first of all, f dash of x is equal to cos x minus sin x. So cos x plus sin x. So next, f dash of x is equal to 0 implies cos x plus sin x is equal to 0. That implies cos x is equal to minus sin x. So what are the values of x? See, here x should be between 0 and 2 pi. Here we know that, see, here it is not sin x is equal to cos x is equal to minus sin x, okay? And we know that cos minus pi by 4 is 1 by root 2, right? That is, cos minus pi by 4 is 1 by root 2. Why? Because cos of minus theta is cos theta itself, right? That is cos pi by 4. So cos pi by 4 is 1 by root 2. And sin minus pi by 4 is equal to minus 1 by root 2. Okay. Here, according to this, here we can say x is equal to minus pi by 4. But this x should be between 0 and 2 pi. Here minus pi by 4 does not belongs to this interval, right? So here minus pi by 4 is not included. Okay. So then next value. Here we know that 3 pi by 4. See, it should be multiple of pi by 4. Okay. If we, in this equation, see, it should be satisfied the values 3 pi means multiple of pi by 4. Okay. What about 3 pi by 4? What is sin 3 pi by 4? See, sin 3 pi by 4 can be written as sin pi minus pi by 4, right? That is sin pi minus, see, 4 into pi, 4 pi minus pi, that is 3 pi by 4. Okay. So here pi minus pi by 4, it lies in second quadrant, right? Pi minus. If it is, see, it is pi by 2, pi 0, okay, 3 pi by 2. See here pi minus means it lies in second quadrant. In second quadrant sign is positive. Therefore it will be sin pi by 4. That is 1 by root 2. Okay. And what about cos pi by 4? Cos 3 pi by 4. Cos 3 pi by 4 is cos of pi minus pi by 4. That is cos pi minus in second quadrant. In second quadrant cos is negative. Therefore it is minus cos pi by 4, that is equal to minus 1 by root 2. Okay. So it will be satisfied here. Right. So here and also x, this 3 pi by 4 belongs to this interval. Okay. Therefore one value of x is equal to 3 pi by 4. And also we know that sin 7 pi by 4. See, 7 pi by 4 is also, see how can we write? Sin 7 pi by 4 is nothing but sin pi plus, so 2 pi, okay, 2 pi plus pi by 4, sorry, minus 2 pi minus pi by 4, okay. So here also 2 pi minus means it is 2 pi, right? It is 2 pi. 2 pi minus means fourth quadrant. In fourth quadrant sign is negative, right? So here it will be minus cos pi by 4. Right? Minus sin pi by 4, that is minus 1 by root 2. Then what about cos 7 pi by 4? Cos 7 pi by 4 is here minus, see, in the fourth quadrant cos is positive, right? So here cos 7 pi by 4 is cos 2 pi minus pi by 4, that is also cos pi by 4 itself, that is 1 by root 2. So here 7 pi by 4 is also satisfied in this equation, and we have to check whether this 7 pi by 4 including in this interval. Yes, obviously this 7 pi by 4 is including, right? 8 pi by 4 is not included, right? Okay, so 7 pi by 4, x is equal to 7 pi by 4. Okay, so more than of this will not including in this interval. Okay, so here, so we have got two critical points, x is equal to 3 pi by 4 and x is equal to 7 pi by 4. So let's check one by one. So let's find f double dash of x. What is f double dash of x? It is our f dash of x, this one. So cos x derivative is minus sin x plus cos x. That is cos x minus sin x is the f double dash of x. Now let's find f double dash of 3 pi by 4. That is cos 3 pi by 4 minus sin 3 pi by 4. What is cos 3 pi by 4? We have already found it, right? Cos 3 pi by 4 is nothing but minus 1 by root 2. Okay. Minus, what is sin 3 pi by 4? Sin 3 pi by 4 is 1 by root 2. That is equal to minus 2 by root 2, that is minus root 2. Okay. Minus root 2 is less than 0. Okay. Therefore, by the second derivative test, we say 3 pi by 4 is a point of local maxima. Okay. Therefore, 3 pi by 4 is a point of local maxima, and local maximum value is that is f of 3 pi by 4. Substitute x is equal to 3 pi by 4. That is sin 3 pi by 4 minus cos 3 pi by 4. That is equal to, here sin 3 pi by 4 is 1 by root 2 minus cos 3 pi by 4 is minus 1 by root 2. That is 1 by root 2 plus 1 by root 2, that is 2 by root 2, that is equal to root 2. So here 3 pi by 4 is a point of local maxima and local maximum value is root 2. Okay. Next we will find, see this one. That is x is equal to 7 pi by 4. So here f double dash of 7 pi by 4 is equal to, substitute here x is equal to 7 pi by 4. Cos 7 pi by 4 is 1 by root 2. Okay, 1 by root 2. Okay, minus sin 7 pi by 4. That is minus 1 by root 2. So it will be minus become plus 1 by root 2, that is equal to root 2. That is greater than 0. Okay. So according to the second derivative test, 7 pi by 4 is a point of local minima. Since it is C, f double dash of C is greater than 0. Okay. So given point, that is critical point, 7 pi by 4 is a point of local minima, and local minimum value is 7 pi by 4 is a point of local minimum, and local minimum value, that is f of 7 pi by 4, that is equal to sin 7 pi by 4 is minus 1 by root 2 minus cos 7 pi by 4 1 by root 2, that is minus 2 by root 2, that is minus root 2. Okay. So minus root 2 is the local minimum value of the function. Next function is f of x is equal to x cube minus 6x square plus 9x plus 15. Important question. Okay. So find the maxima, local minima and local maximum minimum values. Okay. So for that, first of all, let's find f dash of x, that is 3x square minus 12x plus 9. Okay. Then f dash of x is equal to 0 implies 3x square minus 12x plus 9 is equal to 0. Here 3 is common. Let's take it out. 3 into x square minus 4x plus 3 is equal to 0. That implies 3 into, see here we have to write it in the form of x plus a into x plus b to find the values of x. Okay. So here 3 into, multiplication should be 3 and addition should be minus 4. That is minus 3 and minus 1, right? So x minus 3 into x minus 1. See, multiplication is plus 3 and addition is minus 4. So here x minus 3 is equal to 0 implies x is equal to 3, and x minus 1 is equal to 0 implies x is equal to 1. So 1 and 3 are the critical points. So next we will find f double dash of x. That is, it is our f dash of x differentiated with respect to x. that is 6x minus 12. Okay, then let's find f double dash of 1. So here we have to check whether this greater than 0 or less than 0. Okay, so f double dash 1 is equal to, substitute x is equal to 1 here in f double dash of x. So 6 into 1, 6, 6 minus 12, that is minus 6 less than 0. Right? So here we have got f double dash of 1 is equal to 1 less than 0, that is f double dash of c less than 0. So by the second derivative test we say 1 is a point of local maxima, okay, and local maximum value is when x, substitute x is equal to 1 in f of x, okay. That is, therefore 1 is a point of local maxima and local maximum value is f of 1. Okay, substitute x is equal to 1 in f of x, okay, not f dash of x or f double dash of x. To find the maximum value or minimum value, you have to put the corresponding critical values in f of x. Okay, so here f of 1, that is 1 minus 6 plus 9 plus 15, that is 10, 4, 19, right? 19. So here local maximum value is 19, okay, and this function has a local maximum at x is equal to 1. That means 1 is a point of local maxima and the local maximum value is 19. So next we have to check at x is equal to 3. Okay, so f double dash of 3 is equal to, it is our f double dash of x, put x is equal to 3, 6 in 3 into 6, 18 minus 12, that is 6 greater than 0. See, here we have got f double dash of c greater than 0. That means 3 is a point of local minima. Okay. Therefore, 3 is a point of local minima and local minimum value of f is f of 3, that is equal to, substitute x is equal to 3, 3 cube 27 minus 6 into 3 square, that is minus 6 into 3 square is 9, that is 54, plus 27 plus 15, okay, that is equal to 27 plus 27, 54 minus 54 cancelled, then answer is 15. Okay, so here local minimum value is 15 and this function has a local minima at x is equal to 3. That is, 3 is a point of local minima and local minimum value of the function is 15. Next function, g of x is equal to x by 2 plus 2 by x. Let's find g dash of x. X by 2 derivative of x by 2 is 1 by 2 and derivative of 1 by x is minus 1 by x square. So minus 2 by x square. Okay. And next, g dash of x is equal to 0 implies 1 by 2 minus 2 by x square is equal to 0. That implies 2 divided by x square is equal to 1 by 2, right? Taken 1 by 2 right side or minus 2 by 2 x square, minus 2 by x square taken right side. So it will be 2 by x square is equal to 1 by 2. Okay, that implies, see, cross multiply. So it will be x square is equal to 4. That implies x is equal to plus or minus 2, right? Plus or minus 2. Plus 2 or minus 2. But here x is equal to minus 2 is not possible because see, x, it is mentioned x greater than 0. Okay, x should be greater than 0. Therefore, x is equal to 2 is a critical point. Okay, only 2. Minus 2 is not possible. X is equal to minus 2 is not possible since x greater than 0. Okay. Then, now let's check about this one. Okay. So, x is equal to 2, that is f double dash. We have to find g double dash of x, right? g double dash of x is equal to, it's our g dash of x, derivative of 1 by 2 is 0. So derivative of minus 2 by x square is minus 2 by x cube, right? Isn't it? That is, we have to find, that is derivative of minus x 1 by x square is nothing but x raised to minus 2. Okay, d by dx of x raised to minus 2, that is minus 2 into x raised to minus 2 minus 1, that is minus 2 into x raised to minus 3, that is minus 2 by x cube. Okay, so here derivative of minus 2 by x square is minus 2 into derivative of 1 by x square is, okay, derivative of 1 by x square is minus 2 by x cube, minus 2 divided by x cube. So it will be minus into minus plus, so 4 by x cube. Okay, next we will find g double dash of 2. G double dash of 2, substitute x is equal to 2 here in g double dash of x. So 4 divided by 2 cube is 8, that is 1 by 2. Okay, 1 by 2 is greater than 0, right? 1 by 2 is greater than 0. Okay, so here we have got f double dash of c greater than 0. Then by derivative test we say 2 is a point of local minima, right? Local minima, and local minimum value is when substitute x is equal to 2 in g of x. Okay, so 2 is, therefore 2 is a point of local minimum. Okay, if it is greater than 0, then local minimum, and local minimum value is g of 2, right? G of 2, that is substitute x is equal to 2 in g of x. 2 by 2 is 1 plus 2 by 2 is 1, that is equal to 2. Next function, g of x is equal to 1 by x square plus 2. So g dash of x is equal to, let's apply quotient rule. Denominator x square plus 2 into derivative of 1 is 0 minus 1 into derivative of x square plus 2 is 2x divided by x square plus 2 whole square. Okay, that is equal to, first term is 0, so minus 2x divided by x square plus 2 whole square. Okay, so here let's apply, it is better to apply first derivative test. Why? Because see, we have to find, for second derivative test we have to find g double dash of x, that is the second derivative of this function, right? It's little complicated, right? Because our minus 2x by x square plus 2 whole square, so we have to find the derivative. So it is better to apply first derivative test. Okay, let's try. So g dash of x is equal to 0 implies, to find the critical points, minus 2x divided by x square plus 2 whole square is equal to 0. That implies minus 2x is equal to x square plus 2 whole square. See, minus 2x is equal to x square plus 2 whole square. See here, this whole square is equal to minus 2x. See here, the only possible value is, value of x is 0, right? Because see, it is square. It is not possible if any value of x, that is except 0, it is minus. Okay, that comes to minus. So here the only value of x is nothing but 0. Okay, no need to simplify and solve. Here x is equal to 0 because we have got minus 2x is equal to this term whole square. This is always positive, right? So the only possibility is x is equal to 0. So x is equal to 0 is the critical point. Okay, now let's apply first derivative test. So we need to find, okay, we have to take 2 points, that is immediate neighborhood of 0, that is less than 0 and greater than 0. That is less than 0 is minus 1, greater than 0 is 1. Okay, take 2 points, minus 1 and 1. Okay, minus 1 and 1. Okay, so here g dash of minus 1. What is g dash of minus 1? It is g dash of x, right? So minus 2 into minus 1 divided by x square, that is minus 1 square is 1 plus 2 whole square, that is 2 divided by 3 square, that is 9, it is greater than 0. Next let's find g dash of plus 1. Okay, g dash of plus 1. That is equal to, here substitute minus 2 into 1 divided by 1 square is 1, 1 plus 2, 3 whole square, that is minus 2 divided by 3 square, okay, 3 square is 9, it is less than 0. See here, g dash of x, the sign of g dash of x changes from positive to negative, okay, that is our first derivative test. If the sign changes, f dash of x changes sign from positive to negative, then we say the function has maximum value, okay, maximum value at x is equal to 0. That is, here 0 is a point of local maxima, okay. Therefore 0, because here g dash of x changes sign from positive to negative, okay. It is positive and it is negative as x increases, okay, as 0 increases. That is why we have taken these values less than 0 and greater than 0. So we have to, here you should be careful. See, you should find first value is f of g dash of minus 1 itself, okay. You have to find g dash of minus 1 first, okay, then find g dash of 1. So if the sign changes from positive to negative, then it has maximum value, okay, and if the sign changes from negative to positive, then it has minimum value, okay. So here 0 is a point of local maxima, and local maximum value is local maximum value is f of 0. That is, f of 0 is, sorry, g of 0. G of 0, okay, not f, g of 0, that is 1 by 0 plus 2, that is equal to 1 by 2. So 1 by 2 is the local maximum value of the given function. Next function is f of x is equal to x into root of 1 minus x. F dash of x is equal to, here x less than 1, okay, f dash of x is equal to, we have to apply product rule, x into root of 1 minus x, derivative of root 1 minus x is 1 by 2 root 1 minus x into derivative of 1 minus x is minus 1, okay, plus root 1 minus x into derivative of x is 1. So let's simplify this one. So minus x, here let's take LCM, so it will be plus 2 root 1 minus x into root 1 minus x, that is 2 into 1 minus x divided by 2 root 1 minus x, okay, that is equal to minus x plus 2 minus 2x divided by 2 root 1 minus x, that is equal to 2 minus 3x divided by 2 root 1 minus x, okay. So f dash of x is equal to 0 implies 2 minus 3x divided by 2 root 1 minus x is equal to 0. That implies, see, if we take this one right side, so we will get 2 minus 3x is equal to 0. That implies x is equal to 2 is equal to 3x, okay, 2 is equal to 3x. That implies x is equal to 2 by 3, okay. So 2 by 3 is belongs to this interval, that is x less than 1, so 2 by 3 is less than 1, okay. So here, see, here also we will apply first derivative test, because see, we have got f dash of x itself for this one, right? So we need, for second derivative test we need to find the f double dash of x. It's little complicated, right? So it is better to apply first derivative test, okay. So here f dash of x, that is critical point is x is equal to 2 by 3. So let's take neighborhood points, that is 2 by 3, that is here less than 2 by 3 is nothing but 1 by 3, and greater than 2 by 3 is nothing but 3 by 3, that is 1, okay. So let's find f dash of 1 by 3, okay. 2 points we have taken, that is 1 by 3 and 3 by 3 that is 1. Okay. So here f dash of 1 by 3, here it is our f dash of x. So 2 minus 3 into 1 by 3 divided by 2 into root of 1 minus 1 by 3, that is equal to 2 minus 1 divided by 2 into root of 3 minus 1, that is 2 by 3. Okay. So that is equal to 1 divided by 2 root 2 by 3. See, it's always greater than 0. Okay. Next, let us check about f dash of 1. Okay, f dash of 1. Substitute x is equal to 1 in f dash of x. 2 minus 3 into 1, 3, that is divided by 2 into root of 1 minus 1. So here it is, see, it is, here we are taking, that is neighborhood value, that is just greater than 2 by 3. Okay, so here 3 by 3, that is nearby 2 by 3, greater than 2 by 3, that is, it is very close to 1 and but less than 1. Okay, so that is why this value. Okay, suppose, see, if we taking 0.9, okay, if we taking 0.9, so it will be 0.9. okay, because we are getting 1 minus 1 is 0. Okay, that's why I am telling here we are taking the values very close to 2 by 3 and less than 2 by 3 and greater than 2 by 3. Okay, so less than 2 by 3 we have taken 1 by 3 and greater than 2 by 3 it will be 3 by 3. Integer means it is 1, that is here we can take 0.9 also, that is also very close to 2 by 3. Okay, and greater than 2 by 3. So here if we take 0.9 for example, so it will be minus 1 divided by, that is 2 into root of, okay, 0.1, right? So here see, it's always less than 0. Okay, it is always less than 0 because minus 1. So here the sign changes, that is f dash of x sign changes from positive to negative, right? Positive to negative. Therefore, according to the first derivative test, we say here this point, that is 2 by 3 is a point of local maxima. Okay, local maxima, because this f dash of x sign changes from positive to negative. Okay, therefore 2 by 3 is a point of local maxima. See here, you should not be confused here. Okay, because here we are taking some values that is less than 2 by 3 and greater than 2 by 3, because here our test is nothing but, see, as x increases. Okay, that is why we are taking a very close, the values very close to critical points, less than of that and greater than of that. Okay, that is very close to 2 by 3. So here if we take 3 by 3, 1, it will not be defined. Okay, that is why I have taken 0.9. That is also very close to 2 by 3 and greater than 2 by 3, right? Okay, so that is why, see, here we have got, here we have to check it is less than 0 or greater than 0, not value or value of this point. Okay, so here 2 by 3 is, we have got, according to the first derivative test, 2 by 3 is a point of local maximum, and local maximum value is f of 2 by 3, that is equal to, here substitute x is equal to 2 by 3, 2 by 3 into root of 1 minus 2 by 3, that is 2 by 3 into root of 3 minus 2, 1, so 1 by 3. Okay, that is 2 divided by 3 root 3. Okay, root 1 by 3 means 1 by root 3, right? That is root of 1 is 1 itself. So 1 by root 3. So it is our maximum value. Okay, 2 by 3 root 3 is the maximum, local maximum value, and 2 by 3 is a point of local maximum.